All right, today's experiment is going to be to experimentally determine the molar mass of butane. And the chemical formula of butane is C4H10, so you can immediately figure out its molar mass using the atomic weights of carbon and hydrogen. But in this lab, we're going to try to calculate it experimentally by using the ideal gas law. Okay, and to do that, you are going to have this is a butane cylinder, which contains butane gas. That's a refillable one. And the first thing in the lab that we're going to do is we are going to measure its mass. So we'll put it on the balance beam and record its mass in grams. Then, as you can see here, I have the setup of the apparatus. In this, I've got a graduated cylinder that is filled with water all the way to the top, and I have placed a tube in it, which is connected to this little mechanism called a gas collection tube. Okay, I'm going to attach the butane cylinder to it and simply discharge some of the gas into that cylinder, all right, and fill it as full as and fill it to a certain amount. Okay. All right, now, once we've collected the sample of butane, we're going to take down the other measurements needed in the data table, and I will give you the completed data table. One thing I wanted to mention to you guys is that when we collect gas using water displacement, okay, here's the technique that you just saw. Once the gas is discharged, it creates pressure and it pushes the water out, and we now get our gas collection. It is very important that our water levels are equal, right? Right now, if you look at this situation, you can see that the water level right now in the graduated cylinder is above the water level in the beaker. When that happens, the pressure inside of the gas and the outside are not equal. So what we need to do always in these types of labs, which you might see in the national exam, is you have to make sure to move the graduated cylinder so that the water levels are inside and outside are equal. When that is the case, the pressure inside and outside are equal. The pressure outside of the cylinder is called atmospheric pressure, which I can easily measure, and that'll be recorded into your data table. Okay? When I collect gas using water displacement, the other issue with it is that along with collecting the gas, we also find that some water has also evaporated as the gas bubbles through it. So there's more than one gas that I've collected. So I have to get rid of that contaminant, which is the evaporated water. And one way we can do that is look up on a table of water vapor pressures. This is temperature dependent. So when you get the data table, based on the temperature of the experiment, I will report the actual vapor pressure of the water. So now, when you look at each of your trials, you'll have an atmospheric pressure and a water vapor pressure. And for all the trials that might be the same, they might differ slightly, but it's not going to have much difference of change. But by knowing those two, we should now be able to figure out the pressure of the butane. I am then going to take, so now in the lab experiment, I'm going to equalize my water levels. And now once they're equalized, I can now record what the volume of the gas is. And it looks like I'm at 86 milliliters. So I'll record that into the data table. I will then take the temperature of the water. Now, the temperature of the water, we're going to make a big assumption here, and that's going to add some air into it. But we're going to assume that the temperature of the gas is the same as the water. So when you see the value of the temperature of water in the data table, that is also going to be the temperature of the gas. And it looks like I got a value of 21.7 degrees Celsius. Okay. The last thing that I'll need to do is to determine the atmospheric pressure. And the way that we can do that is by using a barometer. So in the classroom, I have a barometer. And right now, the barometric pressure is at 100.8. So the atmospheric pressure for today is 100.8 kilopascals. The water vapor pressure, because I'm at 21.7 degrees, I'm pretty close to 22, 2.643 kilopascals. And the last thing I'll need to do is to get the mass of the butane cylinder after gas collection. And that will then give me, okay, the mass before and after. Since I know the mass of the cylinder before discharging and after discharging, I can't measure the mass of the gas directly. But I can measure the cylinder, and the amount of mass change of the cylinder should be equal to the amount of gas that escaped it. And therefore I can figure out the mass of the gas indirectly. Once I have all those measurements, okay, I can then use the ideal gas law to figure out the moles of each of the trials by using the pressure of the gas, not the pressure of the atmosphere, not the pressure of the water vapor, but the pressure of the butane. The volume, the ideal gas constant we're going to use is going to be 8.314 because we are in units of kilopascals. These are not units you're probably going to see in the national exam, but it's what my barometer measures in, and therefore that's the R to use whenever you are in kilopascals. And then the temperature. Make sure your units are in liters and kelvins so that they cancel and you'll get the moles. On your green sheet, both the ideal gas law is present, but also this equation is also on the green sheet in the same section, and big M is the molar mass. N is the moles of gas, M is the mass of the gas of the trial. Rearranging this equation, you should then be able to solve for big M, which is the molar mass of butane. And this is how you will experimentally determine the molar mass of butane for each of the trials. I'm going to give you 3 trials of data, so you will do this 3 times to calculate the mass of each of the trials. We'll see how good Mr. K does. And then you will go ahead and calculate the molar masses of the 3 trials, and then calculate the average of the 3 trials, and then do a percent error, and then you have some questions to answer on the template, and this template will be in the virtual laboratory that you can pull up. Once you've got all those questions answered, take pictures of that and upload it into Canvas. If you have any questions, don't be afraid to contact me.